The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Depending on where you're logging in from today, one of those will sound just about right. Welcome back to another great episode of our Best Practices webinar series with 7Signal. I see several of you have dropped in early today. As always, let us know where you're logging in from. If you are working remotely from home, if you're in the office today, what part of the world you're logging in from, let us know. I am back in our Cleveland headquarters office, and I am joined yet again by Jim Vajda in Cincinnati. How are you today, Jim?
Hi, Kelsey. I'm doing well. Spring is starting here, and we're headed for 80 degrees today, so looking good.
That sounds amazing. We have the same weather up here in Cleveland, but I have a feeling we're going to have one more round of cold weather before summer is here to stay. So we'll see how it goes. Fingers crossed. And with that, we do have a couple of you logging in here. We have Olivier joining us from the office in Vancouver. Thanks for joining us. We have Bruce joining us from Erie, PA. Thank you, Bruce, for logging in today. We have Abu joining us again from South Africa. Thank you so much for being here. And I see several more of you dropping in. Keep doing so, and we'll circle back with you later as we go ahead and get started here. So we are 7Signal, the leader in wireless experience monitoring. And as we move forward here, we'll go a little bit into depth as to what our mission is as 7Signal and a little bit about us. So we have a great topic here today, best practices for supporting Wi-Fi clients. And as I mentioned, we will be led today by Jim Vajda, our Chief Wireless Officer and CWNE number 183. And of course, my name is Kelsey Rizzuto. I'm the marketing specialist here at 7Signal. And as we move through the presentation today, if you have any questions for Jim, feel free to drop them in the questions panel, and we can cover that during Q&A at the end of the broadcast. So a couple of announcements before we begin. We do partner with CWNP for every single one of our webinars. So by attending these Wednesday webinars, you are eligible for continued learning credits. So if you're pursuing a certification and would like a PDF certificate, just drop us a note and we can easily send that over to you for attending today. We also host a product tour every single Friday at 12 noon Eastern. So you can go ahead and register at that link, go.7signal.com/tour. And during the broadcast, I'll go ahead and drop that in the chat here if you would like to register and join us this week. We also send out a newsletter every other Wednesday morning, the Troubleshooter newsletter from 7Signal. So if you aren't currently receiving that and would like to, just drop us a note here in the chat as well, and we can get you on our distribution list. We also post the recording and the slides to our Twitter account after every single broadcast. So if you're on there, go ahead and give us a follow at 7Signal. But if you're not, no worries. All of you today will be receiving a recording and the slides from today's presentation in a follow-up email tomorrow. We also post that recording to our YouTube channel, and if you look us up at 7Signal, you can also find all of our previous topics that we've covered as well. So look us up there to watch any of our archived webinars, and we'll go ahead and keep moving here. So a little history on 7Signal before we begin. We were established in 2007 in Helsinki, Finland, and we're now located in lovely Cleveland, Ohio. We've hit a lot of major milestones along the way in our history that we're very proud of, such as the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily as well. We have over 200 customers and 15 patents, which goes to show that the technology you see from us at 7Signal, you're only going to see from us at 7Signal. So to give you a little perspective as to what makes us so different, if you look at your typical enterprise LAN infrastructure here on the right, you've probably got great tools, great technologies installed on the network, giving you really useful feedback and data, such as your Riverbed, Cisco, Aruba, AppNeta, and more. But we live in a different space, picking up where they leave off while remaining completely vendor and device agnostic. We'll start here first with Mobileye. Mobileye gives you full visibility into the user experience from the outside in and can be installed on the individual devices themselves. Mobileye can be installed on ultimately any mobile device, such as your laptops, your mobile phones, pickers and scanners, workstation on wheels, and more. And it can be installed on any macOS, Linux, Android, or Windows device. Additionally, with Mobileye, we can give you full visibility into those external home networks as well. A lot of us here today are working remotely 5 days out of the week or maybe a few days out of the week. And your digital experience matters no matter where you're logging in from. And your work remains mission critical. So getting that visibility into external home networks is incredibly crucial as well. In addition, we do have Sapphire Eye, which are our software-enabled hardware sensors for service-level quality and RF visibility. And through this combination, you're really able to gain visibility and perspective into the network that you just can't find anywhere else. All right, thanks for letting me run through our history for you all. So we're going to go ahead and launch a trivia question before we hand it over to Jim here. So let's see how you all do. All right, Jim, can you see this question?
Yes.
Okay. True or false? Access points have total control over the speed, performance, and reliability of Wi-Fi clients. See several of you dropping answers in. I will give you a couple more seconds. All right, we're going to go ahead and close this out. How did we do today, Jim?
Probably the best we've ever done on one of our trivia questions. A little bit of a softball today, but I wanted to set the tone for what we're talking about in terms of the differences between clients and APs and who's responsible for what part of the equation.
Awesome. Well, great job to you all. Thanks for answering that question for us. And with that, I will go ahead and pass it over to Jim here as he gets set up to talk about best practices for supporting Wi-Fi clients. I think you might be on mute, Jim.
Thank you, Kelsey. Let me just move some things out of the way. Okay, here we go. So my name is Jim Vajda. I'm a Chief Wireless Officer at 7Signal. Had a lot of experience as a wireless network engineer, and you can follow me on Twitter. There's my blog about Wi-Fi and also my amateur radio call sign, all of which you can connect with me with. So today's topic is about supporting Wi-Fi clients, and I want to spend a few minutes making the case that Wi-Fi clients are extremely critical to the overall performance of the Wi-Fi network. One way to think about Wi-Fi is it's really just a network of radios. And some of those radios are access points, but the overwhelming majority of them are client radios. So you can imagine when your wireless network is fully loaded in the middle of the day or whenever that peak load happens, something like 80 to 95% of the radios that make up that network are clients. They're not the access points. So, that could mean in 1,000 AP wireless LAN, 5 to 20,000 clients are nodes, if you will, in that network. And that's important because in the Wi-Fi standard, often this term station is used. And what a station is either a Wi-Fi access point or a client. They use the term station because essentially they are so similar, almost all the same rules and behavior apply equally to clients and access points. So we just talk about stations a lot because they really behave very similarly and actually can actually be the same hardware in some cases. A chipset can act as a client or an access point within the same chipset. And the reason another reason to think about why your clients are so important is that Wi-Fi is uncoordinated. A misconception about Wi-Fi is that there's this access point that is broadcasting a signal that your clients have to receive, and that's how Wi-Fi works. So this is sort of understandable because that's how AM/FM radio works. You've got a big tower with a really fancy radio, 50,000 watts of power, blasting everywhere, and you just have to receive the signal. As long as your AM/FM radio can receive the signal, you'll have a good radio experience. That is not how Wi-Fi works. It doesn't work the way I'm showing it here in this graph. It works more like this, where we have two-way communication between access points and clients, and all the other clients that are connected to that AP, in fact, all the stations operating on the channel of that access point, have to hear the transmissions of each other in order to perform well. And that's because Wi-Fi is uncoordinated. So most of the time, the access point isn't determining everything that's happening on the channel. What does determine what happens on the channel is every station, every access point and client on the channel independently determining if it's okay to transmit or not, what data rate I should use when I transmit, if I need to retry my transmission, and so on and so forth. So the uncoordinated nature actually means that we need really intelligent, well-behaved clients along with high-performing access points to get the most out of our Wi-Fi experience. Another way to think about that, if you're a wireless network engineer like me, you're probably really focused on your access points most of the time. And a way to think about the problem that clients introduce is just this thought experiment. What if all your access points were different model APs from different manufacturers, all running different code levels? Well, it turns out that's pretty much the state of the clients that are operating in your WLAN. They're different make and models. The drivers versions they're running are probably not standardized. And again, that is the large majority of the radios operating in your network are in that state. So I like to think about walkie-talkies and two-way radios as a great analogy for Wi-Fi, partly because the channel access rules are very similar. We're all operating on one channel to communicate with each other, and we're doing that in a half duplex way, which means only one radio can transmit at a time, and that radio can't receive while it's transmitting. So to take this walkie-talkie analogy a little bit further, you can imagine your access point as this really, rugged, high-quality Motorola two-way radio. It's got a nice long antenna. It's rugged. It's been tested and with first responders and high-stakes, mission-critical scenarios, and it's passed all those tests. And it's got high-quality components, and it's great. But in a lot of Wi-Fi networks, your clients look more like this. Little toy radios built as cheaply as possible. Not much of an external antenna. Of course, almost nothing has an external antenna anymore if it's not an access point. Low quality components. And you can imagine if you were trying to use walkie-talkies, and most of them were these tiny little toys, and one of them was this high-end professional radio, you'd have some performance problems. So, the reason for those problems is rarely, it's less often the high-end access point, right? It's the low-end, low-quality clients that potentially are the majority of the radios that are operating in our Wi-Fi environment. So we need to pay careful attention to those clients, just like we do to our access points, if we're really trying to solve the problem of Wi-Fi performance and really optimize the end user experience that comes from Wi-Fi. So how do we do that? So we've made the case that it's really important. I want to talk about a few different use cases and even get into some specific recommendations for some different platforms. So we'll start with BYOD because there's only so much you can do in a bring your own device environment. Thinking of something like higher education, or maybe a business that allows BYOD. The challenge here is you can't control the devices that come into that join your network. You can't control the drivers they're running. You just have to make a best effort to try to make it all work. But what you can do is manage expectations, right? So an important part of working on client issues is working with the teams and people that have the responsibility for those clients. So communication is a big part of this. And managing expectations from the get-go will help. So, the message needs to be, we have a highly tuned, rock-solid Wi-Fi network. We've got great visibility into its performance, and we're confident in it. And hopefully you are. But, let people know, let management know, let the people that are interfacing with those end users know that it's just a fact of life with Wi-Fi today, that some clients are going to perform better than others. Some might not work at all because of weird interoperability issues, driver bugs. Clients do this, very strange things at times. And untested clients are the wild, wild west. Voice over Wi-Fi, in my opinion, I would strongly advise against trying to get that working in a BYOD environment. Voice over Wi-Fi is really hard to get working well, and with uncontrolled clients, it probably won't. And just emphasize that clients are so important to performance, with the end users, that Wi-Fi is much more than what the access point is doing. And understand that end users rarely think about the radio in their client as a potential source of issues. Another concrete step you can take with BYOD is to publish some minimum device requirements. Put them up on an IT web page somewhere. put it, you know, give a printout to incoming students, things like that. I like to say that 802.11ac is a good minimum requirement. And that's not actually because I think the performance that 802.11ac, the features of 802.11ac are actually required today, but 802.11ac only works in the 5 gigahertz band. And if you, and so when a device supports 802.11ac, sometimes called Wi-Fi 5 today, you know it's got 5 gigahertz support. And you really don't want somebody coming in with an 802.11n device that's 2.4 gigahertz only. That's, in most enterprises, that's results in really degraded Wi-Fi performance. It's not that 802.11n isn't good enough for BYOD. It's just that there's ambiguity about what bands are supported by the device, and that doesn't exist with 802.11ac. You probably need to specify WPA2 Enterprise if that's what you're using on your BYOD network, because we can't take for granted that all clients will support that. And don't be afraid, you know, to be a little bit insistent. Make kind of strong claims about you need to follow these specs, otherwise whatever it is that's going on in the organization won't work for you. Because my experience is as soon as these things get published, people start asking for exceptions and yeah buts and well, actually, we already have this device and it's not quite that. Are you sure it won't work? And, you know, the technical answer to those questions is often, well, maybe it's okay, actually, even though it's not quite here. But when you start to kind of get squishy about this stuff, you know, things get a little loose, and next thing you know, you've got a lot of 2.4 gigahertz only devices trying to do things on a high density network that just won't work. So be rigid, I would say, about these requirements. And consider disabling 2.4 gigahertz entirely in a BYOD network. We can't alter the settings on the device to make it prefer 5 gigahertz like we could with an enterprise managed device. You know, we can play around with band steering on a dual band SSID, but I think there, you know, are often better options than that. And I don't like disrupting the natural probing and authentication and association behavior of clients, which is what band steering does. So maybe just turn off 2.4 gigahertz entirely on that BYOD SSID. So enterprise managed clients. Again, a lot of this is process and communication. So don't just stay in your network team silo if you're the wireless network engineer. Go out and talk to the people that are responsible for your clients and maybe your help desk, and educate them on what we just talked about at the beginning about how important clients are to overall Wi-Fi performance, how they're just as important, sometimes more important than access points. Talk to procurement in your enterprise. Those guys are extremely process driven, and you can get embedded in some of those processes. If some other group within the organization is buying wireless devices and you're not aware of it, all of that's going to get funneled through procurement. So, you know, add a step if you can in their process where they check with you, ideally to say yay or nay as far as the purchase goes, but at least to know it's coming, right? You at least want to know something's about to get procured, this Wi-Fi device, and have an opportunity to have some level of input early on in the purchasing process potentially before a mistake gets made. Before purchases happen, for these managed clients, it's really worth taking the time to get a demo and demo unit, do a POC on your network, get some hands-on experience with it yourself, test it for compatibility and performance. Voice over Wi-Fi clients especially have to be excellent Wi-Fi clients, and if they're not, it's just going to be you will regret compromising on voice over Wi-Fi clients. And one particular thing to test is roaming performance, because it's how a client actually roams is rarely documented and often really terrible. So if you're a hospital network with a lot of mobility, if you're in manufacturing and you have a lot of mobility, if you're in, we see this more and more, all wireless offices with employees moving all over the office all day long. Hopefully that, we'll be back to doing that again here sooner than later. Roaming performance is really important, and it's a weakness, to be frank, with Wi-Fi. And the responsibility for roaming performance is on the client side. The client makes roaming decisions, and there's very little we can do on the infrastructure side to influence that. So other things we can do just from a organizational standpoint with these clients is work on developing some standardized, blessed configurations of your devices that you've tested and have given the rubber stamp that they're going to perform well in your environment. And be specific about the wireless adapters in use, the driver versions, if it's Windows and you can alter those things. The advanced driver settings, we'll look at some of those coming up here. So, share that with desktop and help desk. That's a great document that can be used to validate a client first when a help desk ticket comes in or potential Wi-Fi issues is getting troubleshooted. Is that client in the right state that we validated will perform well in our environment? And if not, these standardized configurations give that first line of defense person the ability to say, okay, I need this driver version and I need to tweak these settings, and let's see if the problem still exists. So I guess the whole purpose of this is doing front end work on these projects, on these, when new devices are getting interested or getting potentially procured. Getting involved, going to meetings, talking to people is worth the effort, because if you're investing time on the left side of this flow, it saves so much time and so much pain on the right side once things are deployed into production and the performance characteristics of those clients are really impacting the overall Wi-Fi experience of your end users and the amount of help desk tickets you have to address. So do what you can to get embedded in those processes. So let's get into some specific technical things. So for Windows, we've got a lot of nerd knobs we can tweak with driver settings, which I like. And I'll say right here, I've got a lot of slides with URLs. Don't bother screenshotting or trying to write this down. We're going to share these slides with embedded links. So just look for that from Kelsey as we're wrapping up. But with Windows clients, there are advanced driver settings for each wireless adapter out there that allow you to customize its performance. We'll talk about what Intel offers because that's the vendor we see most often. And the two things I usually want to adjust with Intel adapters are the preferred band setting. So you can set that so the adapter prefers 5 gigahertz access points when it's roaming and only uses 2.4 gigahertz APs as a last case, or when there are no good 5 gigahertz options. And also the roaming aggressiveness. So roaming aggressiveness controls essentially how quickly the device will roam when the signal strength starts to degrade. And it's not exactly clear from Intel what these different values actually mean, because you can go high, medium, high. I think there's low and medium low. Generally, you want to be at medium high or higher, particularly with mobile clients like WOWs and carts that are in use while they're physically moving. You want to increase the roaming aggressiveness. Another thing that's not well known still about Windows 10 is that it has native support for 802.11k, 802.11v, and 802.11r with certain wireless adapters. And that alphabet soup, 802.11k, v, and r, are enhancements to the standard. They're optional features that actually can have a really positive impact on the roaming performance of a client if it supports that. Now, for the client to take advantage of that, you have to enable those features on your SSIDs that they're connected to. So I would strongly suggest that you investigate this as a possibility for your Windows 10 machines and test it and see if it if this works for you, because it really can help with roaming. So for Intel, to use 802.11k VNR with Windows 10, you just need the 7265 or newer adapter, and that 7265 is fairly old. So good chance that most of what you have from Intel on Windows 10 will support these features, and that link there will give you the details on what you need to use those. Another warning about Intel drivers with Wi-Fi 6 or 802.11ax access points. This is a pretty widespread issue, and what happens is with certain Intel adapters running old drivers, they will not be able to connect to an 802.11ax or Wi-Fi 6 access point. So we've seen this scenario where an organization has replaced all their access points, upgraded to Wi-Fi 6 APs, and the next day all their Intel based Windows machines completely lose all Wi-Fi connectivity. And the quick and dirty fix, unfortunately, is to turn off 802.11ax on those access points and operate them in an 802.11ac mode. So the correct way to fix this problem is to update the drivers on those clients before you get Wi-Fi 6 deployed in your network. And this link will show you the specific driver versions and things you need for that. But you really don't want to get into the situation where you've got these awesome new Wi-Fi 6 access points, and unfortunately you have to just turn off all the new features in Wi-Fi 6 for these Intel clients to be able to connect. All right, so let's talk about Apple clients. Apple clients don't have the same level of configurability in terms of Wi-Fi as some others do. So you sort of have to take it or leave it. It is what it is, and there's only so much we can do to affect their performance. One thing that really does affect their performance are operating system updates for macOS or iOS. That's when there's potential for driver updates, changes to roaming algorithms, bug fixes. Those are all packaged into operating system updates in the Apple ecosystem. And for iOS, luckily iOS clients tend to be pretty well behaved. They have broad support for 802.11 kVNR, and their roaming threshold is minus 70 dBm. So stickiness issues and poor performance issues are not especially common with iOS. And Apple's published a document that describes or really sort of outlines their roaming algorithm, which is definitely worth a read if you're supporting iOS clients. macOS is a very different story. I don't think it was designed to support mobility the way iOS was. So there isn't currently support for 802.11 kVNR, but the macOS is very tolerant of those features. So if you have all that stuff enabled on an SSID, and you also support 802.1x authentication without fast transition, then your Macs will connect and not have any issues. The roaming threshold as published is minus 70 dBm, but I'll say from experience that macOS roaming is unpredictable, and I wouldn't want to deploy Macs where I needed mobility to work really well. It's just a challenge with macOS. Apple has a document there as well that describes macOS roaming and how the algorithm was intended to function. And a really good reference for iOS support, whether you're a Cisco customer or not, is a best practices guide that Apple and Cisco developed. Enterprise best practices for iOS devices and Mac computers on Cisco wireless LANs. But a lot of what they talk about in this guide is Wi-Fi design. It's a lot of stuff that's not necessarily specific to Cisco environments only. So I would suggest looking through that, whether you're a Cisco customer or not, if you're supporting Apple clients in the enterprise. So let's talk about Android. So what makes, one of the key characteristics of Android is it's an extremely fragmented ecosystem. It's an open source operating system, and device manufacturers can take that code and do whatever they want with it before their devices are sold. And that's good and bad. But from a Wi-Fi perspective, it means that we can't always know what the specific Wi-Fi performance will be for a specific device model. So we really need to test them individually because they could be unique. Android supports 802.11 kVNR. Older versions don't. Not every handset does. So that's something to investigate on a device-by-device level. And some Android devices have specialized configurability options for Wi-Fi settings. Thinking of voice over Wi-Fi handsets from Zebra and Spectralink and others, you can go in and specify what channels they'll operate on, what RSSI threshold they should roam at, and more. And you should go in and tailor those to your environment and test them and find a blessed configuration, if you will, for those devices as well to optimize their performance. Like the Apple ecosystem, driver updates and Wi-Fi bug fixes are bundled into operating system upgrades. And a reference for looking at the roaming performance or the roaming algorithm, at least for Samsung's devices, is this enhanced roaming algorithm document they've published, where they've also published that minus 75 dBm is their roaming threshold. So I want to talk about what our own solution in Mobileye can do to help with some of these client-side issues. First, Mobileye, in running on the endpoint as an agent, can collect a lot of valuable inventory data about the client population in general. So instead of going out and getting hands-on with all your clients to figure out what driver versions and adapters they're running, Mobileye can gather all that up and present it in a simple report like this, where you can see all the various driver versions you have for your adapters and make and model computers. The next step that you can take with Mobileye is to use that for reports. So we can correlate the roaming performance of certain adapter and driver combinations and see what combos in your environment are having the most issues and which are having the least. So you can see on this report that Intel 7260 adapter with that the oldest driver version we have there, that 17.15.0.5, has had far and away more roaming issues in this environment than the 7260s with more recent drivers. So this is really helpful for discovering what's working and what's not, understanding what the specific clients are that need to be addressed, and then finding a new driver to land on that might help improve the situation. So really handy tool from us to help sort some of these things out. All right, I think Kelsey, with that we can do a little Q&A before we wrap up.
Great. Thank you, Jim. And as Jim mentioned, just a reminder, these slides will be posted to our Twitter account later this afternoon, and all of you will receive the presentation slides in a follow-up email tomorrow. So all of the resources that Jim has listed out will be accessible to you, so you can go back and look at those. And with that, we did get a couple of questions here, so we'll go ahead and start with one from earlier in the webinar. Kimberly wants to know, is there a client you recommend for those who don't have another option than voice over Wi-Fi?
Is there a client you recommend for those who don't have another option than I'm not sure I quite understand the question. Don't have another option. In other words, if you have to do voice over Wi-Fi and you'd rather not, is there a client that, okay, I think I get it. So in my personal experience, the handsets that are purpose-built and dedicated for voice over Wi-Fi tend to outperform the smartphones, whatever the make and model is, when it comes to voice over Wi-Fi performance, and definitely outperform soft phones running on a PC for voice over Wi-Fi performance. So that's where I would start looking.
All right, thank you, Kimberly. Thank you, Jim. Another question here from Thomas. Thomas is asking, how do you deal with hundreds of Wi-Fi devices, for example, in a university dorm? Can disabling the SSID broadcast help?
Yeah, I would recommend against disabling the broadcast of the SSID, as in hiding the SSID name. Particularly in a BYOD environment, that's going to make it more difficult for clients to get configured properly and discover your SSID. How do you deal with the hundreds of Wi-Fi devices in a dorm? Well, you need a high density design. So you really need to very carefully design and follow the best practices for designing for high density and capacity in those dorms. And really, you want to maximize on the capacity side as much as possible, because Thomas, to your point, you don't know what students are going to show up with every year, and they may have new applications that demand more and more throughput and performance every year. So by delivering the most capacity possible, that's going to help you address that in the best way possible too.
All right. Thank you. I think we have time for one or two more questions here. Jim, we have a question from Tim, and he says, any thoughts on improving your overall security via 802.1x versus WPA2E?
Yeah, so WPA2 Enterprise is the Wi-Fi Alliance branding for doing 802.1x authentication over Wi-Fi with some specific encryption algorithms and a defined security scheme. Improving overall security, if we're still talking about the client side of things, one of the most important things to do is make sure your clients are validating that server certificate that the Radius server is presenting. If they're not doing that, then you don't have mutual authentication, and then you leave your clients open to rogue access point attacks. Maybe another step after that is to move to using machine credentials if you can for your clients. So not using your for example, Active Directory username that's your name and your Active Directory password, but actually a unique set of credentials just issued to that device for authentication. That can be helpful for improving security too, overall. So a couple ideas for you there, Tim.
All right, thank you, Jim. I think we have time for one more question here. We got a question from Mike, and he wants to know, when migrating towards 5 gigahertz only, how do you balance work from home limitations?
Yeah, well, so it depends on the environment. So if you are sending access points, remote APs or Office Extend APs home with your employees, then you could enforce a 5 gigahertz only network configuration. I think as long as your clients support that, I would recommend doing it. I think there might be even more urgency in a work from home environment because particularly in dense residential areas, the 2.4 gigahertz band is going to be pretty ugly. So you really don't want your employees using that band at all if you can avoid it.
All right, and with that, I think that's all we have time for today. Thank you to everyone for dropping questions in the questions panel. We love hearing from you all every week. And a huge thank you to Jim for walking us through this great topic of supporting Wi-Fi clients. So thanks everyone for being here, and thanks for giving us 49 minutes out of your workday. So hope to see you at next week's webinar. Thanks, Jim.
Thanks, Kelsey. Thanks, everybody.
Bye, everyone.